Hey everybody, this is Larry. This is me going Q2 of the weekly kindness 47, final element after subarray deletions. Hit the like button, subscribe, and join me in Discord. Let me know what you think about this one. So this one was the hardest one for me for sure. Yeah. Let me bring up a train brush. I'm not gonna lie. I talk about this a little bit after I solved it. If you want to watch the live portion, and you skip to the very end, I talk about this. But honestly, the way that I came up with the solution is very silly. I mean, I validated afterwards. Well, I submitted it and then I validated. But honestly, the way I came up with this one is honestly, and it took like 10 minutes anyways, or 15 minutes, something like that, which is long for a Q2, right? The way that I came up with this one was just going, wouldn't this be funny if this was the solution? Basically, right? Because I was like, this is Q2. It's clearly like a weird tricksy problem because if it's not, it very much feels like an n squared dynamic programming solution or something like that. Maybe n cube with depending on how you word it. But because n is so big, it almost kind of forces you to have a greedy-ish solution, right? And I don't, it doesn't have to be the solution that we came up with, but I was just thinking greedy more like, oh, there's some like weird sorting or something like that. So I was trying to think about it along those way. But honestly, I don't know how to tell you how to solve this, right? I can only explain the solution for you on this one because this one, I don't know how to solve it. In the sense that like I came up with it eventually because I was like, wait, wouldn't it be silly if this is the case? But then it turned out to be true because we watched the live portions, skip a little bit, you'll see me do it and you'll see my expression because that was this is a silly one. But the idea here is that, okay, let's say you start with a subarray, right? And yeah, so let's say Alice gets the first move. So Alice can basically the two things that Alice can do, right? There are many things Alice can do, but without loss of generality, let's just say A is less than B, right? Because if not, you could just flip it. If A is less than B, then Alice, and maybe there's like some C in the middle. But the idea here is that, okay, and maybe C is smaller than A or B, right? But so there are really two moves. There are a couple of moves, but you could enumerate them. You could just take this, and let's just say C is the smallest number, right? You could take this, but then now, by extension, Bob, I mean, and there's just some recursiveness problem with it, but you could say that, at the very least, Bob can just remove this, right? And with Bob remove this, then A is the answer. But just by, just by the first move, you can force a better solution. I thought I changed the colors, but it's very silly. But you could force B just by choosing this, right? So therefore, you would never choose C or anything in the middle, subarray in the middle. Because if you choose C, like I said, then Bob would just delete this thing and then you already get a smaller answer. And then the question is, well, then what do you do? Well, one way is, of course, you just take everything and then pick B. But and that may be fine, but with that, it's hard to kind of understand the thing, right? Well, the idea, though, I mean, I wouldn't say this is a proof, but one idea that I would say is that because if let's say there's another, okay, let's say there's a D where, I don't know, you could just say D is bigger than, so this is the biggest number, you want to keep it maybe, right? Then now, if your first move is this, then Bob will just, well, with the same kind of recursive logic. I say recursive is not quite the right word, but it's because in this idea of optimality, meaning that Alice and Bob has the same strategy. I mean, they're reversed. You could say put a negative number on them to make it like increasing or decrease or maximize or minimize. But the idea is still that you have the same thing, and they just like almost the same thing but opposite. And then Bob could just remove this thing, forcing the B, because why leave this D, right? And the same thing that we said before, right? If Bob had chosen something in the middle, then Alice would force the D and be like, at the very least, and that's already better than just B, right? So that means that Bob would just do this and force B, right? So that means that even if Alice doesn't force B, Bob will force B anyway. I mean, of course, that's assuming that you have D is bigger than B. If you have, I don't know, if you have some D where it's A, I mean, I guess that is, what would Bob do? Well, Bob would just, I don't know, Bob would just remove this, and then now you have D, and then because you have D, and when you could have a B, then Bob laughs at you for being stupid, and that's it, right? So in this case, Bob would not remove, Bob would be happy that you chose a D that's smaller than B. Right, and those are the two cases. I mean, I guess you could also choose the case where, there's a C here and you stop here, but then that's just like, I don't know, what are you doing? You're not even, But that's basically the core idea about the structure of how I would put a proof. It's not a strict mathematical proof, of course, and the code obviously is not very interesting. It's then now you have the first element or last element. And that's it. That's how I would think about it. But I can't really tell you, like, and honestly, I cannot really tell you how to solve this because I don't know. Validating it, even validating it took long. I was kind of more, when I submitted, I YOLO'd, and then I was like, well, if it's correct, let me try to prove it, But I think I just look at the example. I stared at the example long enough. I said, wouldn't it be fun? I mean, and you kind of see how they kind of structured in a way so that they weren't giving things away. And it always looks obvious in retrospect, but I was just like, maybe they're doing this on purpose. Like maybe it's just like the first and the last. And I say it that way, but of course there's a little bit of intuition there, right? Because after 15 minutes of thinking, I didn't know that obviously Alice can always force the first or last number, right? So that's always a choice you get to make, right? So that's kind of the idea. But yeah, a very long video for one line of code, but that's all I have for this one. Let me know what you think. Let me know how you did on this one. I hope this one was interesting, but I thought it was funny, but and the video, even the explanation is shorter than I solved it. But anyway, thanks for watching, and you can watch me solve it live during the contest next. No silly mistake, please. Thank you. If you know me, it's been a lot of silly mistakes lately. But all right. Alice and Bob, subarray LR. I should use the best one first, actually. But any subarray such that the length is strictly less than that, I guess. All right. 10 to the 5th is interesting, actually. I was going to write some DP, but okay. So Alice is trying to maximize. Bob is trying to minimize. So what am I trying to do? Does it have to be prefix, suffix? No, or anything? Just take anything else. Well, I mean, this is such a very specific thing and very unfortunate that it got cut over 2 lines. But it's just a number. That means that you always leave one element. So Alice or Bob always just leave one element or 2 elements, right? Well, Bob really has no choice. So Alice either leaves 1 element or 2 element. Well, I guess, yeah. Maybe that's not always possible if it's subarray. Okay, so Alice is going to try to reduce all the minimal elements, right? So what does that mean? So you take the smallest element and then you keep going. That's interesting. It's such a weird constructive problem. Maybe there's an obvious answer. Alice will always, alright, so just always improve on the answer by deleting the minimal. right? Is there a binary search of like Alice's moves? Huh, I don't know that I know this one. This is such a weird one. I mean, okay, you remove the minimum one, and then Bob will return the maximum in the same way. But it's just reverse, right? Because you just could negative the array. But it assumes that Alice and Bob knows that. Can I think of it backwards? Wow, for Q2, I'm just like stumped, honestly. Because, alright, let's play around with some numbers, maybe. I don't know. I mean, in this case, you would just remove this and you're done, right? What if the maximum number is here? Remove this, then they remove this, and then it'll be 5. Remove this, will still be 5, but I don't know. But you definitely remove this because then now the answer is at least 4, right? And then now Bob. So if it was 5, 1, 2, 3, you would just remove this. But if it's on a 2, then you would remove, I don't know. Is it binary search? Is there a weird binary search answer? Man, this is gonna kill me on the rankings. I mean, it's okay. I don't even have any idea. My idea would be DP, but 10 to the 5th is obviously too big. Is there divide and conquer? No, I don't think so. Subarray. Must be some funky things. Definitely on a constraint though. Wow. I mean, you definitely want to remove the bit smallest number. But it's not the median number either, right? Because if you have someone like this, then definitely do, and you're done, right? So you want to remove, like if there's like, I don't know, I guess if they're bigger numbers, but what if there's a 6 and then like a 1, 2, 3? Do you remove that? Like, do you just remove all this? I guess not, because if you remove it, then that just takes one more turn for, like, this one doesn't take an extra turn, but it could have taken an extra turn for the max anyway. And then the question is, if you decide between this and this, does it matter? Maybe it doesn't. But then how do you choose to end here at 4? Like, at what point, what number do you choose? Wow, I'm so lost. Am I misunderstanding this? It's either that, I mean, there must be some like weird trivial thing that I'm missing. I have to come back to this, honestly. It doesn't happen that much that I'm skipping Q2, but I have kind of related, but yeah. Leetcode is so dumb. But okay. I still didn't get this one though. How do I get it? Do I period from the to the end answer? I go this number. Okay, so at the very least they remove one bad number, right? Can I do a binary search? Was binary search I mean, can I even? But then it's iterative. And then I don't know how to do it quickly, huh? How did I do? Did I get one? Oh, what was my other wrong answer? I don't remember. A lot of people got Q2 though, so maybe it's some dumb thing that I don't know about. Everything I don't know is dumb, of course. I'm just saying it. Now, I mean, just in case you not realize, I was just kidding. But I am the dumb one. I mean, the idea makes sense. I just don't know how to make that fast. Is it going to be stack related? How do I simulate that? So you could take all the numbers. What is the condition in which you take all the numbers? But it's a subarray, so you don't keep one. You just remove that one. So it could be like a suffix or something. Okay, let's see if I can do induction. If the max score is at the end, then obviously Alice wins, right? Okay. Then if not, then what happens? Okay, let's say there's max here, right? Then what does Alice try to do? Would Alice try to remove everything? I mean, no, because you know that Bob would do it afterwards and maybe leave you with a small number, right? Okay, so this didn't really help. Well, okay, so if this is the case, then what happens? Well, that means that without loss of generality, the min number is going to be on one of the sides. So then you just take all this and then, I guess it's a sorting thing, right? Is it? It's just about taking the smallest number, but also taking other smallest number next to it. So you have a thing, you sort it, take it from one end as much as you can, and then the greedy would, okay, so you sort, consume from the front, do you though? I mean, do you greedily take from the front though? Because there could be a case in which I really have no idea. I still have an hour. I didn't pick up because he's talking to Q2. Okay, let me expand this a little bit more. All right, so we have 152, which is example. So then, okay, so what happens? If the numbers in the middle, and there are more numbers, do you take these? Maybe, right? Because 2 actually makes it interesting. Because, no, they'll just take these 3, but we could probably make it interesting. Right, like, okay, so I take the 1, and now what? What would Bob do? Has to take the 5, and then Alice takes the 2 2s, right? But if Bob does not take the 2 5, someone like this, Alice still wins. Someone like this, then it's still 3 anyway. Not win, but what did I do? Oh, hopefully that didn't do anything. I don't know why I just pressed. Is the answer always the first number or the last number? Because, okay, if the first number... Because you can always force it, right? But is it? But why would you always force it? Well, if it's min number... Well, if... Is it always at the end? Is that the trick? I mean, that's... I don't even know, but I just feel like that would be one of those annoying tricks that Leetcode would do for dumb reasons. But why would that even work? Okay. Like if the min numbers are ordered in the middle, then you would just get rid of them anyway. So you just pick one of the... Like I'm almost wanting to write... What happens if there's only one element? I guess this would still work. But I don't know. I'm gonna yell... I don't know what I'm doing, so... Oh. Honestly... Huh. I still don't get the logic, to be honest. I think some of it is just noticing a pattern, but not even like a good pattern. It just feels like, I don't know. I feel like I'm cheating in a way because I'm like, if I were to screw around with a Q2, what would the answer look like? Honestly, that's my thought process. Like, and I was like, well, I mean, the examples are 3 elements and 2 elements so that they can maybe do it this way. And like, so honestly, like, no joke, I still don't know why this works at this moment. I mean, I'm done, so I'm just talking about it a little bit. So I don't know why it works. But I was just like, well, Alice has the first move, so Alice gets to choose, like almost like a reduction thing, right? Like if it's one of the ends, then Alice gets to choose, right? Because if that's the optimal solution, then it has to be you choose you take. There's some like game theory thing where Alice just gets to choose, and if Alice chooses to keep one and can only choose one element, then this would be the answer. That's how I kind of was like, I guess it could be possible, but I'm still trying to think. I mean, there is some like maybe recursive thing of like, okay, if Alice does anything else, maybe that's it, right? Like, if Alice does anything else, then you could say that, well, okay, without loss of generality, if Alice takes a prefix, which assumes that this number is bigger than this number, that A is less than B, and just put here, well, by definition, Bob would always take the 10 and then maybe cut you off to the min number. Eventually, I guess the game theory will always work out so that you get to the B. Because if B is the better number, then you would just cut in. And that's suboptimal, right? It's suboptimal because Alice would not leave you a choice So in a recursive kind of way, because would you ever take stuff from the middle? No, because by then you have the induction, because it's suboptimal, because Bob would choose one of the two in the opposite way with the same principle of, well, removing one of the ends and then forcing you to choose something like that. You choose on the inside, and then they remove B, which by definition would be smaller than the one in the middle. Well, I guess I buy it, but this is ridiculous. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, the explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.